Okay, so because we spent so much time going over the test, this is going to be very, very brief here. We'll talk more about this also again tomorrow, and there is a video on the support materials part on Canvas. So, but the idea is if we're looking for powers of different integrals that have different powers of sines and cosines, or secants and tangents, or cosecants and cotangents. I've also put on there, right underneath on the very top, I added on that double angle formula that's sine of 2 theta is 2 sine theta cosine theta. That will come up a few times kind of unpredictably, and I don't expect you to memorize those, so you can reference there. The rest of the sheet, like, and we just said this a moment ago, but so that we know, you can use that on the test. You can also use it on the semester final exam. It's going to kind of walk you through the idea behind it. But in a bigger sense, what we're trying to do is when we have various powers of sines and cosines is if there's an odd power, we're going to pick one of those off to use as du. Because we're going to have a choice of calling either u sine x or d or u cosine x. Either way, the du is going to have the other one. So if we choose u to be cosine x, we need a sine x for du. If we try to say u is sine x, we need a cosine x for du as part of that. Now we also know that even powers of sines or cosines could be traded in for the other, from the fact that sine squared plus cosine squared is equal to 1. So we could say sine squared is 1 minus cosine squared, so we can get rid of even powers of n's and sines and convert them into cosines, or vice versa. So if we have an odd power of 1, the idea is we're going to save that one off. So since we have an odd power of sine x, we're going to kind of pick it off and save it to be a du. So that means we're going to commit to calling u cosine x. So this will be part of the du. And then what's left is, since we took one of those away, now that becomes an even power, which we can trade in for cosines. You with me, or am I going too fast? Okay, so then we can trade in the sine squared for 1 minus cosine squared x. We still have this cosine to the 4th x, and we're preserving, but we're going to use this sine x that's going to be part of our du. Is that okay? So we distribute all of this mess over there, and we're going to get two different integrals. But they're both going to have the same u substitution. So this is going to become cosine to the 4th x, and it's going to bring along its sine x dx to use as the du. And then we'll get the minus, and that'll be a cosine to the 6th of x, and it's going to bring along its sine x to use as du as well. You with me there? And so then we can say that, okay, in both of these, we have the same substitution, that u is going to be the cosine. And the du is going to be a negative sine x dx. So our dx will need that extra sign, which we have intentionally set aside for just this moment. And so it becomes the integral of u to the 4th. We've got our sine x dx that we're going to trade in the dx, though, for a du over negative sine x. So that's why we carried that sine x all along, because now we have an integral that we can do. And similarly, we've got u to the 6th, and that sine x we need for our du over negative sine x, and that'll become a plus integral u to the 6th du. And then we can do this integral, so that's going to be a negative u to the 5th. This will say 1/5, and now 1/7 u to the 7th. and then we'll go back to our u's, which were, in this case, cosines. So a negative 1/5 cosine to the 5th of x plus 1/7 cosine to the 7th of x plus c. Now, there's a few twists and turns, but I don't think I can cover all those in 2 minutes. So and it walks you through on that sheet, which is not to say that's necessarily easy to do on your own, but you can try it tonight on the homework and use the sheet as a guide, because it will kind of say, you know, if you see an odd power, this is what you're going to do. If you don't see an odd power, like you have an integral of sine to the 4th or cosine to the 4th or something like that, you're going to go back to some of those formulas we did way back in AP Prep when we talked about the formulas, and I said then, it may not seem like it makes sense why we do these power reducing formulas or whatever. One day you will see why it is useful, and today is that day. You'll get to see. Hopefully you remember, if not with fondness, at least doing some of those and see its usefulness. And we'll talk more about this tomorrow as well, and like I said, you may have to use that support video, so I'll walk through it all.